Yesterday's class, just to let you know, yesterday's class was kind of like a standalone topic. It really is not going to incorporate it into the rest of the unit, which is on quadrilaterals. I had to find a place years ago to put this topic, interior and exterior angles of a polygon. I figure we're talking about quadrilaterals now, so I put it in there. So I know usually most our units just piggyback on the day before and the day before that, but this won't. Okay, so this is just a standalone topic, but yeah, it'll still be on Tuesday's quiz. So let's actually get into the unit right now, which is quadrilaterals. Up on the board and in your packet, you guys have the family tree. These are all the quadrilaterals we are going to talk about this unit. I want to introduce them to all of you first. Okay, so you know the names of them and also why. Take a look at the tree here. Everyone see there's 3 different groups. Why are they in 3 different groups? I want to talk about that too. So welcome to the quadrilateral family. So let me introduce you to the 3 different families of the quadrilateral family. Anybody? Well, first, let me, the old parallelogram, pop a parallelogram here. Let me introduce you to his family right there, the parallelogram family. Who's in the parallelogram family? What do you think just by looking at those? Who's in the parallelogram family? Yeah, Rosie, the rectangle. You got it, Eva. Yep. Rosie, the rectangle. Anybody know who this is? That's Randy. Yep, the rhombus. Why is it underneath parallelogram? Here's why. Anything the parallelogram has, property-wise, so do these 2. All right, so do these 2. And at the bottom?
Stacy.
Susie. Now, don't get all weird and awkward on me. Like, oh, it's right underneath rectangle and rhombus, so the 2 kids got together and all of a sudden Susie. And that's not how we roll in here. All right, that's not how we're rolling. Susie is the golden child of the family. Maybe some of you can relate. I certainly can. All right. Why is it the golden child? See how it's on the bottom? That means anything the parallelogram, rectangle, and rhombus have, so does the square. It's got everything. Anything we talk about property-wise, the square is going to have. So last thing here before we move on, why are these all grouped together? Why isn't, the rhombus over here? Here's why. All these figures, both pair of opposite sides are, remember that symbol? Parallel. Both pair. That's why all these figures are grouped together, because their opposite sides are both parallel. That is not the case in the next 2 families. So rectangle, rhombus, square, parallelogram, opposite sides are parallel. Not the case in our second family. Anybody know who the second family is here based on the way I've drawn these? You've seen these before, these shapes.
Trapezoid?
Tony, the trapezoid, yes. Who else could be with the trapezoid right below? The souped up version, version 2.0. Isaac, the isosceles trapezoid. He's got a little bit more extra than Tony. Let me turn this over to you. Why are these guys grouped separate from the parallelograms? Tammy, go ahead.
Only one pair of parallel.
That's it. They don't have both pair. They only have one pair. Correct. And then we get to this one. No pair of parallel sides. The outcast, the black sheep of the group of the family. Now maybe some of you can relate. And this would be Kyle, the kite. Yes, a kite is an actual polygon, quadrilateral, that we will be talking about. And it is all by itself because it has no sides that are parallel. It has some properties, but no sides that are parallel. So these are all the quadrilaterals we're going to study this unit. We're going to talk about their properties. We're going to do algebra, and we're going to do proofs with each of them. Any questions on the characters here of the family? Today, tomorrow, Friday, all focused on one and only one, the parallelogram. So let's start there today. There it is, the old parallelogram. First thing, before we even start sniffing a parallelogram, how am I going to write my shorthand? Because let's be honest, does anybody want to write the word parallelogram every time? Claire, do you want to write it every time probably? No, right? I want to do some shorthand, abbreviations. So here's the abbreviation I'll use and you are allowed to use for parallelogram. Everyone remember that was the symbol for parallel, right? The two vertical lines. Dash, ogram. That's how we're going to abbreviate parallelogram, all right? Parallel dash ogram. If anybody ever says 11ogram, get out of here. This one in particular, let's call ABCD. Parallelogram ABCD. We got to talk about something now then. With a triangle, did it matter? Like if I called it triangle ABC, did it matter when you put A, B, and C?
Yeah.
It did?
Oh, no, now when you're proving it, no. Maybe, no. I thought you were
Anybody translate that right now?
I thought you were talking
Translate.
about,
I don't even know what that language that was. Anybody translate what
I
Paul
thought you were
just said?
talking about, like, when you're trying to prove two triangles congruent. Then it does matter how you...
Good save. Good save. Good save. But labeling a single triangle, did it matter? No, it does now. When you label any quadrilateral, it matters how you label it. So go ahead, put vertex A anywhere you want. Who cares? Put vertex A anywhere you want. Now, as you label it, ready? It's got to go clockwise or counterclockwise. You can never jump diagonally. All right? So when you label a quadrilateral, it has to go clockwise or counterclockwise. And if you're wondering why it matters, because if you jump diagonally, the diagonals are going to change. Okay? The diagonals are going to change. And diagonals are going to become sides when they're not supposed to. All right, let's finally get into it. Properties of a parallelogram. There are 5 on here. Just a little challenge. Period 2, your counterparts that you just crush every test, got 4 out of 5 without me saying a word. Can you do it? You already know one property already from the tree. What is it? You already know one from the tree. Jonah, save your classmates.
Both pairs of sides are parallel.
Okay. You're missing a word in there that I need.
Both pairs of opposites.
Thank you. Opposite is the key. Opposite sides parallel. So go ahead and mark those with your arrows. Opposite sides are parallel. Perfect. All right, what else do you think? And they just guessed, by the way, and they were correct because it's not that difficult to guess these. Matt!
Opposite angles are congruent.
Ooh, whoa, yeah, that's the first time I heard that on number 2. Opposite angles are congruent. Good work. So B would be congruent to D, and separately A would be congruent to C. Opposite angles are congruent. Claire, you think you got one for your crew?
Opposite sides.
There you go. That's the one that usually comes up. Opposite sides congruent. Good. Hash mark, 2 hash marks, 2 hash marks. Yes. Opposite sides are congruent. Ooh, anybody got, oh, here we go. Here's the clincher. Anybody got the 4th one? Eva, you think so?
All the interior angles add up to 360. Oh wait. Oh, the exterior angles?
Well, they all add up to 360 and so do the exterior, yeah. But that's any quadrilateral. Like I want some that are just for the parallelogram. Like these here, these don't happen in the trapezoids, but 360 does. So I'm looking for exclusive to our parallelogram. Uh-oh. Oh boy. Yeah, pick your poison right now. I don't care who goes.
Is it same side angles add up to 180?
He's actually correct. Yep.
Let's go.
But here you go. Remember during our parallel line unit, same side interior angles are supplementary. So D plus A equals 180, A plus B equals 180, and I can go around. So instead of saying same side right now, I'm going to say consecutive. Consecutive angles are supplementary. Consecutive. So again, A plus B, angle A plus angle B equals 180, angle B plus angle C equals 180. All right, nobody ever gets the fifth one unless they've cheated and they know already. Anybody want to take a wild guess? I don't even have it drawn in on the diagram, so that's the other reason why this is tough. Quan, you're probably cheating, but go ahead.
Is it the diagonal?
No, they are not. But it has to do something with the diagonals, though. Good. It has something to do with the diagonals. They are not congruent. Diagonals are not congruent. But, Serena?
They form congruent triangles, the opposite congruent triangles.
That is true. That is true. Not this property, though. That is true. Here you go. Let me mark the diagram, and you tell me now. Ready? 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Anybody got a nice vocabulary term? What's happening with those diagonals? You think you got it there, Avery?
The diagonals bisect each other.
There you go. They bisect each other. They cut each other into two congruent parts. Good. Diagonals bisect each other. Fifth and final property. And there it is. There are our properties. Never given to you on a quiz or test either. Challenge, honors kids? Little challenge before we move on. Everyone see where the diagonals intersect? Give me a vocabulary term for that point. That's 3 or more. Where 3 or more intersect, not 2. That is the what of each diagonal. That point is the what of each. Look at AC. Congruent. What's that point then? Midpoint, correct. Their point of intersection is the midpoint. Of each diagonal. All right, let's apply them now. Let's apply these properties to some algebra. What do you say? I'm just going to warn you, these are going to be pretty easy. It's only day 1 or 2, but 1 on the parallelograms. All right, find x. What do we know about the 10 and the 2x minus 4 from our properties? They are congruent. So no big deal here. 10 equals 2x minus 4. Yep, boot the 4 over. We get 14 equals 2x. X equals 7. Great. That's not what I'm concerned about. It's the next part. Theorem used. This is the same one we're going to put tomorrow in the reasons column when we do proofs. What property did we just use? Matt, what property did I just apply? Diagonals bisect each other, but I need a little more than that when you write it in your reasons column tomorrow. What did you already know this figure was? Okay, so here's how we're going to write it. Parallelogram, because I knew it was a parallelogram. Parallelogram implies my arrow. Remember those days? Now tell me Matt again, what was the property? Diagonals bisect each other. We okay? Real quickly, number 2. What do you got for x? 16. I'm not even going to ask. More important to me is tomorrow when we start doing proofs. So now I'll write parallelogram implies what property am I using here? Opposite sides congruent. And just one more. Anytime I'm doing the sides and diagonals are always easy. 3x minus 2 equal to 4x minus 10. X equals 8. What theorem did we use here? Okay. Parallelogram implies diagonals bisect each other. Good work, guys. Good work. Any questions from you? Okay, that's no big deal. Here's where you're really going to start challenging yourselves and everybody else in your group. Angles. I'm going to give you 45 seconds. That's all it should take. Find angles 1, 2, and 3 in number 4. Question number 4. Find angles 1, 2, and 3 in your group. Should take you about 45 seconds. Look, use your properties, right? Use your properties. Use your properties. Angles of a parallelogram. Use your props. Use your properties.
So 2 is consecutive to 3. So if this is 140 because they're across from each other, this is going to be 40. And since 3 is congruent to 1, that would be 42.
All right, time's up. Here we go. Angle 1, what do you have? 40. Consecutive angles are supplementary. Property we went over. How about angle 2? 140. Opposite angles are congruent. And then number 3, 40. You could use opposite angles again or consecutive angles supplementary. Are we all good? Please don't go on to number 5 yet. I want to prove a point and then I'll let you guys go on your own. Okay, number 5. I want to do angle 3 first. Angle 3. And I want to do it without saying these 3 angles add up to 180. So I'm going to do 180 minus 113 minus 45. Right? How else could I get to angle 3 without doing the triangles? There's one property we have yet to speak about. And that is opposite sides are parallel. That's huge. Huge. Why? What type of angle is angle 3 and 22? Remember those days? What are they? Don't forget about them. Alternate interior angles. So that's 22, angle 3. 22 right away. Don't forget about alternate interior. Last thing I'll leave you with. Hold on. Last thing I'll leave you with. Especially when you get to number 6 in your group. It is okay to use things that aren't parallelogram properties. What do you know about 72 and angle 2? They're what type of angles? Okay. So use it. And also, wait! Maybe finding an angle that's not needed will get you to a numbered angle. So it is okay to find an angle that's blank that might lead to a numbered angle. You guys are on your own. 5 and 6. Go ahead. 5 and 6.
Okay,
Was there any angle and any problem that caused any issues? What, Mahmood? In 6? Okay. Now look, I'm going to approach this one way. I'm sure your classmates go, well, I did it this way. I did it. Okay, great. Good for you. I'm going to do this one way. You see 47 and 72? I know it's blank, but I'm going to find the third angle in that triangle. And that third angle, 61. Why do I want to find that third angle? These opposite sides are parallel, and 61 is alternate interior with 1. Okay?
I thought you said we couldn't find the angles in the triangle from 180 minus.
No. I apologize, Kate. I meant I didn't want to do it that way on this one to show you about alternate interior.
Oh,
I don't care how you get there, honestly.
oh,
No. That's, you can always use that. Yeah, I just wanted to show you that these were alternate interior instead of just doing 180 minus it. Okay, good little teaching technique they taught me in school. All right. Good, Mamoon? Anybody else? Trouble? All right, let me go back to number 5 and do the rest of those angles. Angle 1, 113. Opposite angles are congruent. And angle 2 was 45 because it was alternate interior with the given 45. Next up, angle 2 over here was 72, little vertical angle with the given 72. Angle 3 was 108, linear pair with, what am I doing? Angle 3, 108, because it was linear pair with the given 72. And angle 4, what I have there, 32 degrees. All set? Issues? All right, now let me get to the, before we do this problem, there's, thank that didn't burn me. All right, before we get to this, you will have graphing problems tonight on homework. And the graphs, not optional. Not optional. All right, so please, if it says graph, I think there's maybe 1 or 2 problems tonight. If it says graph, please graph it. If you haven't done so already, go ahead and graph parallelogram X, W, Y, and Z for me. This is asking me, name the coordinate where the diagonals intersect. I do not want you to do this just by looking at the graph. Because you draw your and I don't even care if it's with a straight edge you draw in your diagonals. Your answer could be a decimal. And you don't want to risk it by just looking at the graph and saying, oh, maybe it's this or this. Let's do this algebraically. Here's where the intersection of the diagonals are. What do the diagonals do to each other from property number 5 today? Bisect each other, right? And we also, this is exactly why I went over this. What are we looking for here? Where do the diagonals intersect? At the midpoint. Now, do you think it's going to matter what diagonals midpoint we find? No, they're both the same. You want to find, ready? You want to find the midpoint of diagonal WY? Go ahead. Or you want to find the midpoint of diagonal ZX? Go ahead. They both have the same midpoint. That's why they intersect there, because they bisect each other. They both have the same midpoint. And everyone's waiting for me to stop so I can tell you the midpoint formula again, right? What is it? Midpoint formula? Hi, Caitlin. Come on. Wasn't it? I don't know.
X,
It should be. It is. Not wasn't it. It is.
I think it's X.
No.
It is.
There you go. Confidence.
X to this X second X, like X2 minus X plus X1 divided by 2.
There you go. You're not done.
And then Y1 plus Y2 divided by 2.
There it is. point you get should be look like that point of intersection, right? X coordinate 0, 0 for the x coordinate. How about the y coordinate? This is why we do it mathematically and not by looking at the graph. 1 point, 5. All good? Intersection of the parallelogram's diagonals is at its midpoint. Okay, if it says graph tonight, make sure you graph. Tuesday is the quiz. Tuesday.